What's poppin', dogs? Mr. Allen here. We're about to math it up application style, all right? I'm taking the pontoon boat out for a little cruise, a little boat, float, upriver and back for a total of 9 miles in 2 hours. Now, the river current is 3 miles per hour. We want to know what is the boat speed without any current. Maybe if I'm just like cruising in a lake or whatever, okay? Now, we're doing this in Algebra 2 land. Nothing too crazy advanced with mathematics, and resistance. We're just going to pretend this thing is gliding with no resistance at all. Okay, cool, awesome, wonderful. Let's do this. All right, so let's think about some things here. We got 9 miles, 2 hours, and the river current's 3 miles per hour. And I'm trying to figure out what this boat speed is without any current. Well, I know distance equals rate times time, okay? That's always a cool formula to throw down. And let's say like my boat speed is X, okay? My boat speed's X. We don't know what it is, so we'll assign it as a variable. As I'm going upriver, that current is working against me, right? I'm subtracting that 3 miles per hour from my boat speed. So if my boat was, say, doing 10 miles an hour, upriver, I'm doing 7, and on the way back, I'm doing 13, right? There's some give and take there. So we can generalize this as, so let's say, upriver, we're doing X minus 3, and then downriver, that current is working with us, so it's going to be X plus 3, okay? Again, very basic Algebra 2 land. Nothing too crazy math-wise, all right? So maybe I could try and set up some kind of equations here, but I think I still need to do a little more work. Let's see here. I've got my rate here. I got my total time. I got my distance. I'm actually going to manipulate this guy around a little bit. I'm going to divide by r, thus solving for t. So I'm going to get t equals my distance traveled divided by my rate. Okay. So let's see if we can set up a little equation here. Okay. So total distance is 9 miles, which means I'm traveling 4.5 up, 4.5 back, right? 4.5 up, 4.5 back. So let's see here. Upriver, I'd have my distance, which is 4.5, divided by my rate, which would be the x minus 3, right? X minus 3. That would be equal to my time, which is t, okay? Now for this one, I got the same idea. 4.5 divided by x plus 3. This time the rate is x plus 3. Again, for a total of, well, are these both equal to 1? Because we did 2 hours total. Or if I'm not changing my boat speed, like on my throttle, right, it's going to take longer to get upriver and less time to get back. So I don't really know how to divvy up that 2 hours between these two. Perhaps I can just, hold up, check this out. Perhaps I could just do 4.5 over the x minus 3 plus my 4.5 over the x plus 3 and set that equal to my 2 hours. So we have our time plus our time equals the total time. You can see how we have all these units together. And there's different ways of setting this thing up. But hey, this is pretty dope. Rational equation. I love rational equations, right? So again, we have our time going upriver, 4.5. Our distance divided by our rate is equal to our time that we took to get up there. Then our time to go back downriver, right, equals 2. Total amount of time, 2 hours. Okay. So how do we go about solving something like this? Well, I need to find my LCD, right? I got to find my LCD of this wonderful rational equation. Well, I've got x minus 3, I've got x plus 3. So my LCD is going to be x minus 3, x plus 3. And my preferred way of solving rational equations is to multiply both sides by this LCD, which when you multiply both sides of this equation, each term gets multiplied by the x minus 3, x plus 3, x minus 3, x plus 3, and same with this guy right here. Let's see if I can fit it. X minus 3, x plus 3. Okay, cool. There we go. So everything gets multiplied by that. So the x minus 3's here are going to cancel, leaving me with, we've got 4.5 times x plus 3. Then for this next one, I got 4.5 times, and then we got x minus 3 is left, equals, I really should have written this a little bit lower. Pause. There we go. Now we got some room. We got some room to work now. Okay, so let's see what's going to happen here. I'm going to distribute in, right? And then now let's see. So we're going to have 4.5 times x. 4.5 and 3, 4.5 times negative 3. Those two are going to cancel each other out, aren't they? I'm just going to, boom, it's gone. It's already gone, man. I'm thinking ahead. I'm crazy like that, all right? And then we have equals, and then here we've got 2 times, well, x minus 3 times x plus 3. That's going to be x squared minus 9. Again, the negative 3x and the positive 3x are going to cancel each other out. Okay, I like to look ahead for some of those cancellations because 4.5 times 3, what is it, like 12, 13 and a half, right? So I'd have positive 13 and a half, negative 13 and a half, poof, it's gone. All right, so here I've got 9x, so 9x equals, and here I've got 2x squared minus 18. Okay, so I have myself a quadratic. And sometimes we get into full panic mode when we see a quadratic pop up in rational land. We're like, I don't know how to solve this. You do. We're going to set it equal to 0. So I'm going to have 0 equals 2x squared minus 9x minus 18. And now I can factor, favorite F word, right? I can factor to solve for x. So to do so, let's see here. We're going to have what multiplies to 2 times negative 18, that's negative 36. Got to add the negative 9. That's going to be negative 12 and positive 3. That will multiply to negative 36, add to negative 9. That's Gucci. That's dope. All right. Some people like to just do guess and check. We could do that on this one, but not everyone's comfortable with that. So we're going to have 2x squared minus 12x plus 3x minus 18. And then we've got our first group, second group. I'm going to take out my GCF. So I've got 2x coming out, and I'm left with x minus 6. And over here, I've got, looks like a 3 coming out, so plus 3. Then we have x minus 6. And now I have my two factors, 2x plus 3, and we've got x minus 6. Now, what am I doing with those two factors? I'm going to set them equal to 0. All right, I'm going to set them equal to 0. So I got 2x plus 3 equals 0, and I have x minus 6 equals 0. When I solve that, subtract 3, divide by 2, I get x equals negative 3 over 2. And now over here, we've got x equals positive 6. Now, both of these solutions here work in this, equation here, this algebraic equation that we have going on. But do they both work in the original context of the problem? X represents the speed of the pontoon boat, right? X is my speed of that pontoon boat without current. So this means that no go here. I can't have a negative speed. Again, it's not an extraneous solution in your classic sense here in algebra where it would be like 3 or negative 3, right? But it is extraneous in the context of the problem, whereas you did all the algebra, all the math correct, but it doesn't work in the original context. I'm not going negative 3 over 2 miles per hour, right? No, it's not going to happen. But the 6 here, the 6 means 6 miles per hour. That is my speed of that pontoon boat without any current. So going upriver, we're doing 3 miles an hour. Going downriver, 9 miles an hour, but 6 miles per hour without any current. That is dope. That's awesome. Super rad. And I think I want to take out the boat right now. That seems like a dope idea. You know what I'm saying? All right. See you dogs later.